Exponential functions. That's today's lesson. Our objectives are to evaluate exponential functions and to graph exponential functions. Vocabulary. An exponential function is a function in the form of y equals a times b to the t power, where a is a non-zero constant. That's telling me how constantly it's going up or down by. And b is greater than 0 and not equal to 1. And t is a real number. Again, t could be, real numbers are square roots or negative exponents, fractions, things like that. Okay, so evaluate each function rule for the given value. So we have y equals 5t. And they tell you t equals 2, 3, and 4. I'm guessing I'm going to have 3 answers. So I'm going to do y equals 5 to the 2 power. And y equals 5 to the 3 power. And y equals 5 to the 4 power. I have 5 squared, which equals 25. 5 cubed equals what?
125.
125. And 5 to the 4th power? No, 625. All right, B, I have 10 times 5 to the t power. Again, now you have negative 2. Ooh, 10 times 5 to the 0 power. And 10 times 5 to the cubed power. Okay, let's start with this one right here. Can we have a negative exponent? No. So I'm going to have 10 to the 5th squared. So now I have 10 over what? 25. I can reduce that, can I? What can I reduce that to? 2/5. Or what in decimal? Does anyone know?
40%.
Very good. 0.4. All right. Tell me about 5 to the 0 power.
1.
Equals 1. Very good for remembering all the stuff you've learned from last chapters. So it's 10 times 1. 10 times 1 is what?
10. 10.
Wow. 10. 10 times 5 cubed. What was 5 cubed again? 125, which equals 1,250.
Got it.
Does everyone understand what we need to do with negative exponents and 0 exponents?
Yeah.
Yes, very good. Why don't you try C by yourself? And put me on pause, and when you're done, please put it back. All right, so your answers are negative 18, negative 486, and negative 4,374. So I was asked about this, a negative 2. You can have a negative, you just cannot have 0. That would take away the whole idea of growth or decay. So this is saying negative 2 is just saying this is about decay. Yes, like death. All right. Suppose you have, this is going to be growth. Suppose 20 rabbits are taken to an island. The rabbit population then triples every half a year.
Wow.
That's how, yes.
Wow.
They do that.
Rabbits are very prolific.
They love to breed.
Okay, let's get off the subject.
Okay. The function ft equals 20 times 3 to the t power, where t is the number of half periods. Remember, number of half years or periods, half year periods, models this situation. How many rabbits would be there after 2 years? So first of all,
We have to find out
how many half years are in 2 years?
4.
There are 4. You have 2 half years each year. So now we need to find out how many rabbits, if none of them died. How many rabbits would there be?
1,620.
1,620?
Yeah.
3 to the 4th power is 81, right?
Yeah.
Yeah. So,
We're smart. Just because like example A.
on. Okay, so this time when you graph, they're going to give you a equation. Sorry, go back. An equation. This is the equation they gave you right here. Now, I want you to make a table.
So
Like-
-1, -2.
Yeah, I want to have it where you have 0 in the middle. 0 is always going to be your middle. And you will have -1 and -2 and 1 and 2 on both sides. That means you're going to have negative exponents, people.
Wait, so T is the right number?
Yep.
Right?
Mm-hmm.
Okay.
So you're going to have 3 times 2 to the -2 power, 3 times -1 to the -2 power, 3 times 0 to the negative. Oh, can you have 0? Yeah, you can on the.
You changed it. What happened?
Oh, sorry. Yes, thank you. I was like, what? Something's wrong. Okay, I'm going to do the 3 times 2 throughout the whole thing. Sorry. 3 times 2, 3 times 2. It'd be -1, 0, 1, and 2. Okay, so we have 3 times divided because you have to make it a fraction now because we have that. So that would be 3 times 2 squared. So that would be 3/4. What is 3/4 in decimal form? Anyone know?
75.75.
0.75.
Do you have a split decimal point?
That will help you kind of sometimes figure out where to put the point on the graph.
Kind of, sort of.
Mm-hmm.
Kind of, sort of, maybe.
You're not allowed to get sick. I'm the only one that's supposed to get sick, Joseph. Did you hear me, Joseph?
That's Joseph.
Who was sick?
Not supposed to get sick, Joseph.
Wait, Dylan, did you say that you got rabies?
What? Dylan is crazy, everybody.
What would 3 halves be? I am confused.
1.5.
1.5.
1 and 1/2.
So that would be 1.5. How about 2 to the 0 power? What does that equal again?
1.
Very good. Times 1. That's 3. 3 times 2 to the 1 power. What's 2 to the 1 power equal? 2.
6. No, 6.
Mm-hmm. And 3 times 2 squared. That's 4. Very good. That's 12.
12. Yeah.
All right, then you come over here. Yes, ma'am.
Do we have to write it in like coordinates?
You can, just to maybe help you out.
I don't want to because I am lazy.
Okay.
That does not surprise me. Yes, you.
Wait, you write -2?
Yeah.
175? Okay.
So we graph.
Then you graph it.
0.75. Oh, wait, okay.
All right, so you have -2, -2.75. So it's going to be about right here. If it's not exact, I'm not going to hurt you. -1.
Really?
Maybe.
Uh-oh.
0, 3, 1, 2, 3, 1, 6, 1, 2, 3, 4, 5, 6, and 2,
Oh, so
12.
it's kind of like a slurry kind of.
Yeah, it's going to be a curve. 1, 2, 3, 4, 5, 6. Okay, so it goes up this way. We're just going to... Okay.
What is that called? I know, like, there's a...
It's it's not. I don't even know what to call this. This is a growth, though. I'm going to tell you right now, it's a growth. Why would I call this a growth?
Because you're starting out from negative and ending with a positive?
Very good. You're going up, more or less, with it. Okay.
Up, yeah.
Okay. Notice I stopped the point here and just went up. It's a growth.
Oh, it kind of reminds me of like array in geometry.
Mm-hmm.
The line segment on one side.
Hey, what's
the line
array?
on the other.
I don't define moderate
Okay. What am I going to have on B?
-2, -1.
Very good. You're going to have your -2, -1, 0, 1, and 2.
0.5. -0.5.
I'm going to put my stuff down since I'm having such trouble putting the right numbers down. So 2, 1, 0, -1, and -2. Please do the math
Everybody give this video a like if you're
and
tired.
pause. Now, many photocopiers allow you to choose how large you want an image to be. The function ft equals 1.5t models the new size of an image copied over and over at 150%, where the t is the number of enlargements graphed. Can you graph a function? Can you enlarge a negative amount of pictures? No, you cannot. All right. So I'm guessing we are not going to use negative numbers. You can't even use 0. So we are going to use 1, 2, 3, 4. You do not need to use 5. Don't care. I just at least need 4 numbers on this one.
Yay.
So you're going to have 1.5t, which is 1, 1.52, 1.53, and 1.54. You're going to have to use
A
calculator.
calculator.
And my calculator's not working right now.
I'll calculate later.
You don't want me to touch it, sweetie.
Page 96. 1 through 28.
Hey, did you know that there's a page in the book?
Okay, so here are the points of it. And then I graphed it on the side. Check it out. See that you did it. See how I did it? Put me on pause. Big chance you'll need to because I'm saying goodbye now. Bye.